Okay, let's take our beta and talk about it in a different way and use it in the capital asset pricing model, or CAPM. CAPM starts with our expected return on the market, or R sub M. Now, we talked about this previously. The return on the market is the risk-free rate plus the market risk premium. And that is the amount of return you get for holding risk in the market. You don't want to stand on the shore, that's the risk-free rate. You want to get out of that bay and get into the boats, that is being in the market, and you're going to get compensated for that to the tune of the market risk premium. Now, if we tie that into the capital asset pricing model, which is shown here in the formula, we get the return on the individual security, that's R bar sub I, equals the risk-free rate, RF, plus beta of the individual security, multiplied by the market risk premium, or the return on the market minus the risk-free rate. The return on the market, you take away the risk-free rate and you get the return on the market. And when you start thinking about that, you go, okay, so the market return is going to be 10%, and I have a beta of 1.0, then beta times the market risk premium is going to be 10%. We add back in the risk-free rate of, say, 3.0, and I would expect a return on that stock to be 13%, because it's going to move just like the market, and the market return is going to be the risk-free rate plus the market risk premium. So it would also be 13%. Risk-free 3%, market risk premium 10%, it would also be 13%. So if the stock moves like the market, it should move exactly the same as, or the stock has a beta of 1.0, it should move exactly like the market. Now, there's a couple caveats here. The first one is what we're going to use for the risk-free rate. So Treasury securities are what we use for our proxy for the risk-free rate, and CAPM is a period model. So some projects are long-lived. The average period average period or short-term rates need to be used. As a practical matter, the one-year Treasury bill rate will be assumed as an accurate estimate of short-term rates. CAPM suggests that we should use a Treasury security whose maturity matches the time horizons of investors. But no one knows what that actually is, and it's up to opinion. So as I mentioned with beta, there's a little bit of, I don't want to call it fudge factor, but a little bit of variance in here on exactly how you calculate these things to get a real precise number. Now, this is very important in finance because as we've talked about previously, these numbers that you come up with sound extremely precise. 0.056947 sounds really precise, but it's also based on a bunch of estimates. So it's a very precise number based on a somewhat sandy foundation. It's certainly not on bedrock, at least in finance. So let's take that one step further and go to the expected return on a security. This formula is called the capital asset pricing model. The return on a security, the expected return on a security, is the risk-free rate plus the beta of the security, beta sub I, times the market risk premium, or the return on the market minus the risk-free rate. And so if beta was 0, then the expected return would be the risk-free rate. 0 times the market risk premium would be 0, and the risk-free rate would be the answer. However, the market beta is 1, then the return of the security equals the return on the market. And I gave you a quick example of that calculation previously. So let's take this one step further and do a problem. In this case, beta is 1.5. The risk-free rate is 3%. The return on the market is 10%. If we have those variables, and those variables will be given to you in an equation or in a problem, so you can figure out the equation, the return on the individual security, the return on R sub I, equals 3%, which is the risk-free rate, plus 1.5, which is beta, times the market risk premium. Market risk premium is the return on the market minus the return on the individual security. 10 minus 3 is 7, multiplied by 1.5 is 10.5, plus 3 equals 13.5. So if the expected return on this particular security shows that we would expect a 13.5% return on it, given that it has a beta of 1.5, that the risk-free rate is 3%, and that the market risk premium is 7%. So when you start thinking, or expected market is 10%, either way you want to look at that. So when you start looking at this, you say, okay, what variables could change to affect this? Well, the risk-free rate could change, the market risk premium could change, and the beta of the security could change. So this is an estimate. Be very sure that you understand that this is an estimate, not a given. It's not guaranteed that you're going to make 13.5%. It's an estimate of a way to think about whether this is relative to other investments, as opposed to saying you're absolutely going to get 13.5%. So we're going to tie this in the next couple of lessons into selecting projects, because this formula works well in corporate finance as well as investing. So the capital asset pricing model is the expected return on the individual security, or in the future it'll be the individual project, given a portfolio of other securities. So in this case it was the S&P 500 against one stock. We can use it in other ways coming up. So it's a very simple formula. Obviously it's plug and play once you get the numbers. I will do a video on a spreadsheet of how to calculate beta, or how you can come up with a beta, and the rest of the numbers are pretty straightforward. So let's keep going and look at moving this into corporate finance.